Can you all see the whiteboard?
Yes.
What answers did you get for the first question? Okay, good. 8 is correct. Ishan, can you explain?
Yeah. So basically, I did trial and error. So I just took like a piece of paper and drew a cube, and I just did like everything greater than 3. So I just took the number of sides that are only 1 that are painted,
Mhm.
which that are only painted, that only have 1 side painted, and then for 8 you get 8 times 8, 8 times 8 times 6, no 7 times for the ones that are only 1, you got 7 times 7 times 6, which is 294 sides that only have 294 squares that only have 1. And then, so what I did for how many have none is I kind of just like pictured if you slide one of these cubes outwards, so then you'll have 6. And then so it'll also be 7 times 7 times 6. Then you get 294 equals 294. So the answer is 8.
Okay, good. That's close. I think it should be 6 times 6 times 6 instead of 7 times 7 times 6. Let's double check that. So with one face painted, let's draw something like a cube here. So let's see if each of these faces were divided into 8 cubes, then let's look at which ones would have one face painted. So here, would the cubes on the edge have one face painted or no? How many faces would these have painted?
No.
No. Yep. So how many would these have?
3.
Yeah, so the corners would have 3 and then these edges would have 2, right? So basically we want to count only the faces with one face painted, which is basically the inside of this face. So that's basically all the cubes that are kind of within this area. So how many cubes are in this region? So we basically can't include the one row that's closest to this edge and one row that's closest to this edge. So how many cubes are here?
36.
36, good. So 36 here times for 6 different faces, right? So for one face painted, it should be 6 times 6 times 6 is 216. Now let's think about the 0 faces painted case. So 0 faces painted, which means it has to be inside the cube, right? It can't be on anything on the surface has at least one face painted. So we basically don't want to include each of the sides. So if I basically subtract 2 from each dimension, I want this is one kind of edge of the inside cube. This is another edge, and there's one more edge. They're all the same shape, right? So it's 8 minus 2. So there's 6 times 6 times 6. So that's also 216. So like Ishan said, if you try with 8, you see that both of these should end up being equal. So this is one way. So if you knew the value 8, or if you try different values, you can compute this. So is there any other way to do this that might be with maybe some algebra to get this without trying different numbers? Any ideas? so let's say the length is just n units. We're not setting a value of n. How many of the cubes have one face painted? Just in terms of n. So what did we basically do? We said n, we subtracted the two edges, we considered that square, all of those have one face painted, and then we multiplied it by the number of faces. So what is this? What should this be in terms of n? So if this is n, this should be n minus 2, right? So in this case, this was 8. This was, yeah, good. So 6 times n minus 2 squared, good. And that also includes the next answer, and let's go through that. Okay, so 6 times n minus 2 squared. Now with 0 faces painted, that's the inside cube, right? So in this case, we said it's the cube considering 2 units less on each face. So this was 6 by 6 by 6. And in general for n, if this is n, then this should be n minus 2. So it's n minus 2 cubed. So we want these to be equal. 6 times n minus 2 squared should equal to n minus 2 cubed. So this makes it easier to finish. So if we look at it algebraically, then we can cancel n minus 2 squared from both sides. And you get 6 should be equal to n minus 2. And n should be equal to 8. Does this make sense? Any questions on this? Okay, let's move on to the second question. Okay, I see a few different answers. I don't think I see the right one yet. Any other answers? Okay, I don't think I still see the answer I was looking for, but let's see. Let's start off with one of the current answers, and then we'll see what needs to be shifted to get the right answer. So let's see, Sanvi, how did you get 1/2?
Well, I took for the next 3
Mhm.
coin flips. So there will be 8 possible outcomes,
Mhm.
and you write them out like heads, tails, heads, H, 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 T, T. And if you continue writing, 4 of these outcomes will let Fred win. There's one outcome. There's only one outcome that Jane will win.
Okay, good. So which were the 4 that would make Fred win?
H, T, H,
Mhm.
heads, 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 tails, and tails, heads, heads.
Head, tails, tails, heads, heads.
Heads, heads, tails.
Heads, heads, tails. Okay, so let's think about, so this is a good start. Now let's think about if this covers all the ways Fred can win. Now, one thing maybe we can adjust here is that, so really if it started off with heads, heads, it doesn't matter what happens after that, right? Fred wins. So Fred would get 2 more heads and it would be 10 score for Fred. So we can remove head, 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 and head, head, tail, right? So it doesn't actually matter what happens on the third one. So that's just actually kind of a sequence of 2 leads to Fred winning. Now in sequence of 3 moves, so it could be head, tails, heads. It could be tails, head, head. Both of these would lead to Fred winning. Now, it could actually not end in 3 moves also. So can anyone give me an example of 3 moves after which Fred has still not won yet, but he could still win in the next move?
Tails, tails, head.
Good. So if something like tails, tails, head, so now what would be the score after this?
9-9.
9-9. Good. So what would so the last one, if there was a head, then Fred would win. So this is one possibility. Is there any other possibility for it to be 4 moves, such that Fred doesn't win after 3 but would win after 4?
Heads, tails, tails, and tails, head, tails.
Okay, good. Head, tails, tails. So let's see what that would be. That's 9 to 9. And the last one should be a head. Good. Let's see if we've covered everything.
And then tails, head.
Yep, tails, heads, tails, heads. Good. Okay, did we cover everything? Anything else missing here? Yep, I think we're good. Okay, so now let's look at the probabilities now. So I think the trick here was that it doesn't actually need to be a sequence of 3. There could be some 4 moves sequences if it's still a tie after 3 moves or no one has won. So what's the probability of HH? So this should be 1/4, right? Yeah, good. So H heads, tails, heads should be 1/8. Tails, heads, heads should also be 1/8. Tails, tails, heads, heads should be 1/16. Heads, tails, tails, heads, 1/16. Tails, heads, tails, heads, 1/16. So if you add these up, and I think I see the answer now, 11/16. So 1/4 plus 2 times 1/8 plus 3 times 1/16. So this should give you a total of 11/16. Any questions on this? And so basically the key idea here was to find all the sequences that would lead to Fred winning, which is anything that would lead to a score of 10 with Fred without Jane reaching 10 before that. So that could be a sequence of length 2, 3, or 4, and then adding up the probabilities of all of these sequences happening. Okay, any questions? Okay, last problem. Okay, good. 1/128 is right. Nidhi, can you explain?
Okay, so I actually drew a diagram at first. I took a triangle and I did the 3. So I did the 1 in the middle, and then the 1, and then the 2 above it. Yeah. And then I realized, so if you had that 1 triangle in the middle, and then it would be 4 to the next biggest triangle. So I used just the perimeter. So there was a pattern at the end. So for the 10th triangle in the middle, it would have been, I took it as a 3 units. That's how I counted them. And then the 9th triangle would be 6 units in the perimeter. 8th triangle would be 12 units. And basically every single time was multiplied by 2. So it would be 8th would be 12, 7th would be 24, 6th would be 48, all the way to the 3rd would be 384,
And so 3 over 384 simplified is 1 over 128.
Good. Yep. So yeah, I think the key idea should be that every time you kind of connect the midpoints and make a smaller triangle out of the bigger one, the perimeter is half of the original one, or each side length is half of the original. So then you can, if you start with the smallest one as 1, like Nidhi did, or you could just take the ratio of every consecutive one is a factor of 2. So then the 3rd to the 10th should be 2 to the 7th. Now there's one detail here that let's just talk about. So how do you know that when you connect the midpoints here, this side is going to be half of this length? Any
Because
idea?
it's an equilateral triangle.
Good. Yeah, so good. It is an equilateral triangle. And then, so one thing that you should know is that here is this angle is 60 degrees. And so basically when you draw a parallel line to this line, this triangle here is also equilateral. So we know that the original triangle is equilateral, but when you connect these two midpoints, this triangle is still equilateral. This is what helps you to know that when this is a midpoint of this side, the length of this side should be the same as this and this. So that's good. So now once we know whatever this side length is, let's say this is n, this side length should be n over 2. And based on this pattern, we know that, so every 2, the next smaller one will be half that size. So the 10th to the 9th is a half, the next pair is a half, and basically we can kind of multiply these ratios. We'll see that, for instance, this one is 1/4 the size of the original. So we want to do this because it's the 10th to the 3rd, it's basically repeating this 7 times. So this is 1 over 2 to the power 7, which is 1 over 128. Any questions on this? Okay, then that's it for today's class. We'll see you all next week.
Thank you.
Thank you.
Thank you.
Bye.
Thank you.
Thank you.